Okay, so the software-defined radio, right? This is a really interesting concept because we can actually get into some really interesting frequencies that I'm going to show you a little bit about because you want to know this. And so you're going to need a software-defined radio, and now these usually come in the form, when you want to go the cheap route, comes in the form of a DVB-T television receiver. And it basically allows you to tune it to many more frequencies than it's officially used for. So one of these is this really cool thing called the flex frequencies. Well, they're not really called that, but you know. So when I pipe this into this little software right here, and I'll zoom in on this frequency that I'm picking up here. You can see those little sort of spikes happening, and what you want to see is this this meter blowing out basically, and that will and start collecting frames. My reception is not ideal at the moment, but it's good enough, and you can see right here that yeah, so there is actually data coming through. Let's just go through this. The General Hospital in Lancashire, you know, so what's going on? Unknown. So overridden. This might actually be a page that is overridden, so Lancashire. Well, we're not seeing anything else coming in, but so in Snowdon, I've actually been there, or Snowdon House, flat 20. What do we have here? We do not know. Bleeding. Specify. It's not been specified. Chest, cardiac, back pain, upper. So yeah, you can really see like there's some real paging, medical pagers. Doctors respond to them, nurses respond to them. So the weird thing is, like, okay, listening into this traffic, that's all well and good, you know, that's kind of geekness, and nothing is going to come of that. Like it serves no purpose to really look at this data running around, except like, okay, so we've done this, great. But what if you were to repeat these messages, or even find a way of transmitting on this frequency right here and start putting your own messages in? Like, if you parse this data long enough, you should be able to figure out what the correct way of sending these messages is, so that they will be taken serious. And you could seriously put say like all of the medical system of this city down, because if you were to build little devices, you know, you build little breadboards or little integrated, well, little circuit boards, you know, you get some parts together, something that transmits on this frequency. Shouldn't be too hard to get. Like I'm pretty sure some toys can actually transmit on this frequency. And you can hack those toys to do this, and then just distribute them around the city. So drop them off, and at a certain time they are just set to start bursting out like random medical calls, and putting doctors, nurses, you know, ambulance personnel just on wild goose chases. I think you can seriously mess with this pager system, and I don't understand why this protocol isn't encrypted. Why can I, like, with like 2 clicks of a button almost, I can start tapping into this, you know? I've seen a couple of papers actually describing, so basically the reason why they're not encrypting this is because of it'll probably be mostly related to like governmental bureaucracy, but experts will claim that this system needs to be pretty robust because this is actually used, like these are real calls coming in right here. Here, traffic collision, like that's an ambulance being dispatched probably. I haven't looked into this. There's all of a sudden it's gone completely traffic collision on us. So yeah, that's something big. Everybody is being dispatched. So the thing about this is that sorry, I'm just like looking through this for a bit, but anyways, the thing about this is that where was I going with that? Right. Oh yeah. So why it's not encrypted? They think that if you encrypt this protocol, it will be less robust and it will be not as fast because the encryption will take time to encrypt and decrypt the messages. But I've actually read some papers where this was kind of disputed, and there was this one particular paper that was actually going really in depth on how you would go about encrypting this protocol and how you wouldn't lose any of its efficiency. And that is pretty much a misconception that an encryption layer on top of this will be an inefficient way of dealing with this. There's really no rhyme or reason to think that. So it's really interesting to me because, as I said, like I think you can really inject into this protocol and into this frequency, and I think it's a big attack factor on our society. So any city you live in, any village you live in, maybe a village, but when you start thinking about, how would you go about bringing a big city down? Emergency response, especially medical, is one of the big factors there. Because if you can disrupt that, then you're already a big step ahead of kind of attacking a city's operational structure. And I find that very interesting that this is actually still just used. I mean, as far as I understand it, I'm not a big radio person or like a hacker or anything. The way I'm kind of like interested in my privacy, and with that comes sort of like the way that we observe privacy as a society. And I see more and more people posting on the internet on like, the NSA is doing this, the NSA is doing that, and like thinking that they're actually attacking our privacy. But privacy has been long dead ever since these things were created, because I'm sitting here with a $10 device scanning into the medical pager system. It's this thing. You can see it. It's $10 on Amazon. Like this is what it is. It's basically made to be a TV tuner, a really cheap TV tuner. It comes with a little antenna. It's crap. If you want to go deeper into this, you need a better antenna. But this is doing it for me. Like as you can see, that's completely fine. Like I have a terrible reception, and I'm still getting all the messages right there. So yeah, and especially keep thinking about that. Like this is not an illusion. I could probably build something in a day. Like gather some parts and build something in a day that could inject messages into this frequency and start disrupting the medical response services. So I really wonder how they would respond to that. Would they just kill off the pager system entirely and just use voice CB? But then how would you get a doctor from this operating room to that operating room, or get a nurse from this to that space if you can't page them? I'm pretty sure they don't have each other's phone numbers, or like I want to do some more research into that, but like that's kind of my my findings after basically just arbitrarily messing around with radio a little bit. Like it's that thing, like everybody thinks about the hacks, the big hacks of like and you couldn't even call Sony Pictures a hack, but like, you hear it every day, like, and now this website has been hacked, and these details have been leaked, and Adobe, all the login details have been spread around. But this is a way more deadly adversary, the radio frequencies, because in the end everything turns to radio frequencies, and there have been numerous hacks lately that deal mostly with radio. Radio is where it's at when it comes to our privacy. This circumvents everything from operating systems to standard ways of securing things, and we'll go a lot deeper into this. But yeah, just so I can quickly show you how to set this up. Basically, you need to buy one of these things, or something better, but for now just go with the cheap option. Just buy this thing. You're not gonna need the remote and the CD, just throw that away. Now I've had some trouble myself. I'm usually a Mac kind of person, or a Linux, but I work with the tools that work, and the tools weren't working on Mac or Linux. Like the dongle was unstable, and it was just not giving me anything. So I moved it all to a Windows machine, and got this software-defined radio program called SDR Sharp. So you go to this URL right there. I'm not going to call it out. Just go there. It will land you on the AirSpy product. Look into it. It looks like a cool product. I'm not going to get that now. I'm just going to go for SDR Sharp. Download that, right? Okay, you download it. Let me just get rid of that. You download that. It will put itself in a folder. So go to the folder, unzip it. It'll be a zip file. So unzip it. You won't have this folder, but just hit install.bat. And it will start installing. It will download itself, latest version, everything, create this folder for you. Once you've done that, there's a very important step. When you plug the software-defined radio into your computer, it will, well, especially on Windows, it will try to install some drivers for it. It will probably fail, and even if it doesn't fail, you still need to run this Zadig program right here. So you just run that. And the important step here is to go to Options, List All Devices, and make sure that you choose the RTL device there, and then hit Reinstall Driver. Now, every time you use a different USB port on your computer, you have to do this again. So you have to rerun Zadig, Options, List All Devices, find the RTL device, and hit Reinstall Driver. Sometimes it won't work on a USB port. Sometimes when you do it, and you start SDR Sharp and you try to run it, it will say something like the device is already in use, something like that. Just try a different USB port and run the Zadig program again, and it will work. The important thing as well is that SDR Sharp will probably start you off with AirSpy as the source. You want to change that to RTL SDR USB. Right. Now, that just gets you going on scanning frequencies, and you can look at tutorials or whatever on how to scan frequencies. If you turn this to like 88.0000000, you will probably end up with some radio stations, because that's kind of like where the radio stations sit. Where I am, this is kind of like the exact frequency for me to pick up this particular medical pager. Besides medical pages, I also see a lot of electrical engineers coming floating by when I run this. Now there's another big step to get it piping into the other program, which I will tell you about. Usually this will be set to your output, and the software, the radio signal will be played through your speakers or your headphones, whatever. What I've done is I've installed VB audio cables. Let me just pull that up for you real quick. It's virtual audio cables, and if you're on Mac, I would suggest using Soundflower for this. But basically what you need to do is you need to create a virtual audio cable that pipes the audio from SDR sharp into the other piece of software that I'll talk about in a bit. All you have to do is download this virtual audio cable piece of software here, just install it. It will install some drivers. Unfortunately, it's fucking Windows, you'll have to restart. But after that, you can change this output here in the audio to the virtual audio cable output. So now about the de-modulator here, that this piece of software called PDW. Just Google it and download it. It's as simple as that. There's not really any kind of install stuff here. The only thing you're going to have to do is go to interface and setup, and change. It will be set to serial port, because this software is also used for like actual CB radios and scanners and that kind of stuff. But change it to sound card. Change it to earphone 1, which seems to work the best. The sample rate, make sure that's on 44100, and the sound card. You'll see, if you've rebooted Windows, obviously, you'll see the VB audio cable input or output here, and you can set that to be the input for this program. Now, another important thing is that you go to options here, and you change, well, I've enabled POCSAC decoding, which is the post office protocol, and I've turned on all these things. They weren't turned on, I've turned it on. Just make sure that enable flex decoding is on, and that all these baud rates are active. They're bit rates or they're baud rates. The program says bit rates, so let's go with that. And that's it. And then all you have to do is, you don't have to start this program, it's already running. All you have to do is hit play here, make sure that you're dialed into the frequency, and make sure that you're seeing this output coming in. Now, it might very well be that I've sort of shifted off the frequency a little bit, because yeah, I have. As you can see, sometimes those cheap dongles have a bit of a problem with warming up and cooling down, and they will shift frequencies. They're not very exact, so I had to kind of dial it in there a little bit. And as you can see, you'll see frames coming in, and you see my connection coming back, and unconscious, not noisy breathing. You know, it's starting again. Now, I've seen some people on the internet having trouble with getting actual streaming data here. Some people will tell you to, or some instructional things will tell you to turn this down. That didn't seem to work for me very well, so I had to turn this volume all the way up, and then you know, just make sure that it's coming in really nice and loud here. This probably means that it's distorting a little bit, as you can see. Whoa. What? This this will be probably interesting. This will be probably electrical engineers or something. Let's just have a quick look around here. That's funny. I've never seen that message coming by. Ah. So these are people for some reason talking over a pager still. Website hosts. Funny. So as you can see, more people than just the medical pagers use this. But what I was saying is, this will mean that it's probably distorting the signal a bit, but it's working for me. Only I'll get some garbled messages sometimes. This just means that, you know, you don't have a great connection. I mean, I'm using the default antenna, so that'll be why. But yeah, that's a little bit about software-defined radio, and as far as I got with that.